Hi, I'm Sara Caballero, and thank you for coming for my demonstration for my Google Summer of Code project 3D Visualization API. I just finished and graduated from my bachelor's in computer science in the University of Manchester, and I'm going to do my master's in computer graphics in the University of College of London next year. I am from Spain, and I was awarded with the scholarship of the Google Summer of Code with the team of Liquid Galaxy this year. I have an eternal passion to computer graphics, and with this I'm going to start with my project. As I mentioned, my project is a 3D visualization API. How this happened and what is this? So when I was looking into Liquid Galaxy and what it was, I was quite fascinated by it. And given that I did my final year project in computer graphics and my interest in this area, I thought this could be a really cool idea for computer graphics. I thought, why not making some API, some library for a third developer to be able to create a 3D scene in a traditional way, but for them to be able to see it in a Liquid Galaxy display with different screens and being able to see it from one screen to another. So that is the aim of my project. Of course, this is only for third-party developers. What about people that don't really want to create a whole project to be able to see a Liquid Galaxy 3D project? This is how I thought of an Android application. So the idea of this is that a user could just create that application, put all the details of the machine, and that machine will launch one of the default projects in a Liquid Galaxy display with all their machines. So with this, we can see that there's two parts, the API and the Android app. Let's start with the API. Firstly, let's start talking about what technologies were used in this API. I created with WebGL, which is a 3D library in JavaScript based. It's a web-based library. And this is just to be able to actually create a scene. This is also using in 3GS. It's just to make things easier. 3GS is just a library that has commonly used functions in graphics. Then the second most important part of my technology used in my project. So one of the first challenges is how am I gonna be able to recreate an animation in all machines? How am I able to run an animation in all machines the same way? My mentor recommended me Node.js. With Node.js, this is an environment to be able to open a port, and for any new browser that connects to that port, which would be a socket, they will be sent the appropriate HTML with all the JavaScript files, and it will be able to run that JavaScript file for anybody that connects into that port. This is quite useful for me because that means that anybody can just create a WebGL, and if I launch this server with an appropriate port with that code, then any browser that connects to that, it will just get the same code. I don't need to worry about how am I going to send the right animation and the right code to all the machines, because the server will do that for me. All I need to worry is how am I going to deal with new screens, with new sockets connecting to the server, how I am going to manage them. So with this, I need to subdivide even more the API part into how to write the server, and then of course the API itself. I'm going to call them for library to not get us confused, but the library would just be the collection of functions that developer would use to be able to create the 3D scene. Firstly, the server. The server has two main jobs, scene division and synchronization. For the scene division, the first and hardest part of my project and most important part of my project. Of course, when having multiple screens, I need to find a way of how to send the appropriate information to all of them so that they all looking at the right time. We need to have different perspective to be able to see different parts of the scene. So for this, it's important to note that there are two types of camera view. We have orthogonal and perspective. So for the orthogonal, this is when the field of view is parallel. This means that there's no depth, that for a scene like this, we would see it on the screen like that. And then perspective is a frustum, that would be the field of view. That one is the one that simulates human vision the most. We would be able to see a scene, so this would be how an object would be seen in the two perspectives. So this means that what the server needs to send each screen is where is it going to be looking at. In the orthogonal, this is quite easy. It's a parallel. This means that in order for all of them to continue the field of view, I just need to translate or move the camera to the right or to the left appropriately to a fixed amount. So every time there's a new socket, the server will tell them, hey, move this amount to the left, move this amount to the right. For the perspective, that is a harder part, because I need to find the appropriate angle to rotate the camera in order to see all the scene more. This is a hard task, especially because how much you rotate it depends on the aspect of the camera. But after I found out a function of how much each camera needs to rotate, this is all I need to send from the server. So every time there's a new socket, the server will tell them, okay, rotate by this amount. So now that we figured out the scene division, then the second most important part is synchronization. This is so that all scenes have the same objects at the same position. They are all representing the same animation. Firstly, we need to note that we don't need to worry about static objects. This is because of how Node.js work. It will just recreate the same code in all of them. So if the objects don't change from the beginning, then they will all remain in the same position. We only need to worry about the projects that move, the animations. How do we synchronize this with the server? So the server, every few seconds, it will send a signal to all the sockets telling them to stop the animation. It will then ask the master, the center, what is the position of the objects that have moved? And then the master will send the position of those ones to the server. The server then will tell all the sockets to change it to that position. And once all the sockets have sent the server back the signal that tells the master that the position has been set, then the master can send the final signal for continuing the animation. It might look a bit long, but this is not visible for the human eye. Of course, then we have the challenge of how do we know what objects we need to update? And this is how we go into the library. The library, the functions that we need to worry about for the developer are the functions for animation that make objects change. So luckily for us, there's only a finite amount of animations that can be done, which is scaling, rotating, translating, and change of texture. I just created those functions which do the action as normally. But apart from that, it will also put the objects that are being changed into a list so that when a synchronization happens, the master will send this list of the objects that have changed and the position of them. And we can actually make the synchronization happen of the animation. So with that, we have briefly described what my API is about. Apart from that, I also worked into creating some user controls so that a user can move throughout the scene, go forward, go backwards, rotate. The user controls may look easier than they were actually, because it should be as easy as just translating the camera every time we translate the camera or rotating the camera. However, when you add the different screens and how we have translated them, it becomes a bit more complicated. As you can imagine, especially in perspective view, rotating, it will not only involve rotating the camera, you also need to translate it appropriately. If you add into this the OpenGL pipeline where there's a certain steps that it needs to take in order to render, modifying the camera in the middle of a scene is not as easy as it may look like. For these, I took into my advantage the duality of translation and rotation. This means that when rotating or translating an object, it is the same to rotate or translate the camera as it is to move and rotate the objects itself. So when using the user controls, it may look like we are moving through the scene, but I actually am moving the objects because this was easier for the actual final. It was also hard because when rotating and moving around, it is important when I reset the order of how it was rotated to go back into the same image as originally. And since I don't know what the original image is because it's an API, I need to remember what have been the actions that the user has said, so that when pressing reset, I just need to revert all those actions. And then I also created some sample scenes, which you will see in the demo, but they are supposed to represent some basic scenes. So this scene would be one, some 3D objects, so that that move with an animation from screen to screen, a particle system, so a bunch of particles on the scene, which is an example of generative modeling, and we have a 3D model on the center of the screen. Then the Android app. So the Android app was also a particularly challenging part, and I'm going to explain it by explaining how it is designed. Firstly, the connect option. So the connect was the first thing I did in my application to test the basic functionalities. So the connect button is used for an already running project, for an already running server in a machine that is already open. You can see it, and all I want to do is just to connect to it and be able to move it around with the control buttons. This is how I found the first challenge of the Android app, which is how do I connect to a server, to a port in Node.js from an Android app. Luckily for me, there was quite a few of documentation, so it wasn't too hard to find. And after I figured it out, I was able to connect an Android app as a socket into a server in Node.js. By doing so, I had to modify a bit the server to be able to classify the new socket that is a tablet as a tablet and not treat it as a browser. And once I'm able to connect as a socket, then the screen can change into the control screen, which has the basic screens like with the control functions that I mentioned before. So now that I have figured that out, I need to actually work on the main purpose of of the Android app, which is launching a new project, a new server. So with this, firstly, it will ask for the IP address that the server and the master will be running, and the port. This is to check that the port is available, so that if not, then it can be easily changed. Once the port is added, then it goes into the machine details. This is just the general details for me to be able to access into the machine and actually running something. This was a challenge, which is finding how to SSH in Java. Not an easy task, but once I'm able to SSH and check that the details are correct, I can move into registering the base path. This would be the location of the repository in the masters, which, since it's an API, that means that it can be located anywhere. So I need to know where it is. After that, there's a list of projects. There's a 4 default options demo, which will just run the other 3 buttons to check that, running some control functions to check that they work. And then we have 3 projects, which are the 3 sample projects that I created. There's also an option to register new ones if there's new projects that you want to check. And then when you click on them, it will move to the control buttons, which is the same as I explained before. There's also another button, which is the kill button. This is a very important one, because when launching a new project, of course, the port that it will be held on, it will become busy. So by killing, it will kill the server and the port will be available after that. With all this, I'm going to show you the demonstration of my project.